Hello, friends and students. Welcome back once again. So today will be discussing about a new topic, that is PCB design. There will be a series of videos, like maybe 2 or 3 videos I will make on this, so that you will understand what is PCB, what importance it has, how to manufacture it, how to design it. So in this series today, we will discuss about the first topic, that is printed circuit board PCB production process, how it is made. So as you can see on your screen, in the background, you see a PCB and the components are fixed on it. So why it is important, that one by one we will see. So I will go to the next slide. Right. So first of all, we need to understand the definition of PCB. A printed circuit board or PCB is used to mechanically support and electrically connect electronic component. Please remember, electronic component, right? Electronic components are placed on it, and the conductive pathway will be there. That is, some connections will be there. Tracks, or we call it as a tracks also. Traces etched from copper sheet laminated onto a non-conductive system. Okay. Purpose: provide mechanical support and electrical connections. It is a permanent solution for your electrical connection. That you have to remember. Right. Second is, there are many types of PCBs. Okay. Types. One is single layer. Now, what is single layer? I will just show you with the single-sided PCB is nothing you can see on your screen. This is single-sided PCB. That means when I turn, you will find a copper holes. Okay. This is general purpose single-sided PCB. That means one-sided, there is no copper. Another side, there is a copper. There is nothing that is conducting element on this side. Only on this side, that is, copper is a conducting element. Okay. So this is single-sided PCB. I will tell you another also. So this is also single-sided PCB because the components are from this side. You can see the components are placed on this side, on the soldering is done on this side. This is a driver. Okay. This is a CFL driver or LED driver, we call it as. Okay. Right. This is also single-sided PCB of power supply or some this thing, right? Because the connections are on one side and the tracks are on one side, and the components are placed on the other side. Okay. So this is about the PCB, the single-sided PCB. Now we'll come to the double-sided PCB. Now, double-sided PCB, the components are placed on this side also and this side also. That means the copper tracks or the connection or conducting tracks are present on both the sides. Okay. So it will be like this. So this is also one of them. Okay. You can see this is a sensor, that is RC522 RFID sensor. So the connections are on both the sides. You can see the small connection on the whole are being made. And here also it are. The best example is mobile phone PCB, right? Mobile phone PCB is a multi-layer, right? Not double layer also. It is multi-layer. Double layer means what? Component on this side, component on this side. Like you can see the component on this side also. Okay, the component assembly components are being soldered on this side, and the components are on this side also. Okay, so both the side, if you have components and soldering also, we call it as double-sided. Single-sided, I just now shown you. Then we have multi. Right, this is multi-layer PCB. This one is a multi-layer PCB. So multi-layer means there are 1, 2, and more than 2 layers inside. Where are the layers? It will be inside, right? While manufacturing, they will put the layers on on the top of other, right? So that is the multi-layer PCB. All right. So we'll go to the next slide. And before that, going into the next slide, application. What is the application? Where it is used? Everywhere where we talk about electronic and circuits, everywhere you will find a PCB. Okay. So very, very important component, and you need to know, each and every engineer should know about the PCB and designing of PCB and soldering of PCB. Right. Okay. So we'll go to the next slide. Okay. PCB design schematic. First is how you do. What do you do first? So first we make a schematic drawing of the PCB, right? We use a software, different type of software, KiCad, pads, Eagle. These are the different type of software what we use. Okay. So for manufacturing this PCBs, in manufacturing this PCB, you have to design it first. How you design it? You have to make a schematic diagram with the help of a software. Then only you can design it. Okay, right. So you can see on the screen here. I will just try to show it to you. This is the schematic diagram. This one is the schematic diagram. Schematic diagram to layout. That means in this while designing the PCB on a software or you have some application, you have to design the schematic diagram. Then you have to go to the PCB layout. And PCB layout, you have something called routing. Okay, so that we will discuss in the second video. I will tell you step by step how you will prepare a PCB, how you will design it, and how we can do it. Then the third step comes the design rules. You have to check whether the PCB has been made properly or not, whether there are some mistakes. But to avoid errors, we use DRC, right? In the CAD software, right? CAD software, CAD is a computer aided design for PCBs. Okay, right. Okay. So we'll go to the next one. So here, printing is very important. After finishing all these things, printing the design, that is photo lithography, we call it as photolithography. That means you will make a design like this, like you can see on the corner, on the left-hand side corner, you can see a design like this. So this is done with the photolithography. Okay, printed PCB layout on transparent film. This is a transparent film. This transparent film is kept on the this PCB, that is copper clad PCB, we call it as, and it is printed on it, and with the help of a UV or some other purpose, it is printed on this. So then we'll come to the next process. So step by step, first print PCB layout on transparent film, coat copper clad board with the first photoresist, then expose the UV light through the photo mask to transfer design visually. Okay, photolite or other this thing also is used. So other techniques are also used, but you can, it depends, but the process will be same. Okay, now we go to the next one. So here, etching the copper, that means when the PCB is ready, this PCB is ready, we have to do the etching. Okay, etching means what? Submerge board in ferric chloride or ammonia per sulfate to remove unwanted copper. That means I want only this part, or I want only this PCB to this tracks to come, and rest of the things I don't want it. So removing those things, we call it that process is called as etching. Okay, that is process is called as etching. Wash off photoresist, leaving only desired copper traces. Okay, just now we discussed. Safety notes: using gloves and proper ventilation, because these are all chemicals. These are type of acids, so you have to be very, very careful about this. Okay, so we'll go to the next slide. All right, drilling the plates. Now, for fixing the components in this or anywhere, for fixing the component, we need to put the drilling here. Okay, so drilling process is to be done so that the components or the leads which are there can be fixed. Like suppose this component, this transistor is to be fixed. Suppose this transistor is to be fixed. So how you will fix this transistor? How you will fix this transistor? When you make the holes here. Okay. You can see here 3 holes are there, emitter collector holes are there. Then only I can put the transistor from this side and I can solder it on this side. So drilling is compulsory. Okay, depending upon the size and pitching of the holes. Okay, right. So electroplating holes with the copper for a conductive machine use CNC drilling machine, visually close up and drill PCB. Now what happens? If suppose it's a through hole component, like if you want to go from this side to this side, so you want to have a connection from both the side. Both the side you need to have a connection. So what you will do? You will do the electroplating. You can see on the left hand side of this your screen how the electroplating PTH and non-PTH and how the things are done. Okay, it's a process. That is connection from one track or one side or one layer to another layer. That is calling, we call it electroplating. Okay, now we'll go to the next one. All right. So solder mask application. Now after cleaning with this thing, we have to put a solder mask. What is solder mask? Solder mask is the area surrounded by your holes where you will do the real soldering with the soldering iron. These are the areas, that is, we call it as a protection And apart from this, you will do put some green color or blue color or this thing you can see. Suppose this PCB is blue in color. You can see this PCB is blue in color. This PCB is green in color. This doesn't have any color. Okay, this doesn't have any color. But this color, because the track are hidden behind this thing, because to protect the track, we will put a chemical compound. Okay, the liquid epoxy, green color, or we call it as a liquid epoxy, right? To protect it with the help of a UV light, which will protect the PCB or the PCB tracks. That you have to remember. Okay. So now silkscreen printing. What is silkscreen? You have to understand. Anything which is printed on this, printed like name, this, or D1, D2, R1, R2. These are things which are printed on the PCB. Okay. Like it is given here. Add labels, component IDs, logos, etc. Method, inkjet printing or manual application. Simple printing method. You can use it. Example R1 for resistor, C2 for capacitor. Just now we have seen you. I've shown you R1, C1, C2. It is written on this. Okay, it is already written on this. So you have to understand that. Okay. So whenever there is a printing, that is we call it as a silkscreen procedure. Okay. Now we'll go to the next one. That is surface finish and testing. Okay, this is very important. This is we call it the QC check, right? Quality control analysis, surface finishing. So we have different type of tests, that's hot air sorting, leveling, and electronic nickel imaging code. So these are the different type of level testing methods. Different type of level testing method. If you go deep into it, then you have to study all about this. Okay, about the testing methods and all. But I'm not going very deep because the subject will be very lengthy. Okay. Automated optical inspection AI will be there. And that means physically you can check whether any damage, short circuit, or these things have come in the PCB or not. Okay. That is physical checking. We do it maximum time. Okay. Right. Next slide, we will see final assembly and optional. That is, this is the PCB. Now that this is optional now. Either you can give PCB to the company who has asked you to manufacture it, or if you are a manufacturer, then you have to assemble the component. That means the parts has to be fixed. These are the parts which will be fixed on to the PCB, and the soldering will be done. Two methods, SMT and THT. Through hole technology we use. SMT means surface mounted technology. SMT, surface mounted means what? These are all surface mounted device. Same surface, the device, the components have come. Okay, that is called as surface mounted device. Okay, so two technique. This is through hole. Okay, the component lead is going from here and it is coming out from here. So this is the SMT technique. Okay, this is SMT and this is through hole. This is also through hole, or sorry, SMT one. Okay, this is also SMT. Okay, so I told you this is the function test, power up, signal check. These are the things. After completing, you have to do all these things. That is soldering, then reflow, you have to fix it properly, and the testing part comes. If you are a manufacturer, okay? If you are a PCB designer only, then you will leave this up to, before we saw the slide, we will leave up to that only. Okay, right? Quality control standards, these are very important for the students. Okay, we use different type of standards, but the standard you have to remember, IPC A600. Acceptable for PCBs. That is a world standard for PCBs. It is acceptable. That is, we call it as IPC A600. If you want to study about this standard, you can go to Google and you can just find it out. You'll get plenty of notes related to this. Then you have to find the common defects, like if you have suppose soldered it. So what is perfect soldering, too much solder, not enough solder, cold joints, thermal joints, short circuits, everything you can check physically, and this thing, right? Fixing method, rework, patching, or scrapping. That is, again, the people will be sitting and they will be checking physically, and if there is short circuit and all, with the help of a soldering iron, they will just remove the short circuit. Okay, so that is the process. That is quality control and standard. We got it as. All right. So we'll go to the next one. Conclusion and future trends. Summary: PCB production involves design, etching, drilling, and testing. Trend: flexible PCBs. There are 3D machines nowadays. Now you this thing. For that, master PCB design for next general electronics. Okay, you should all learn PCB design to become a master in electronics. That is the meaning, or that is the thing what you have to understand. Okay, please remember, this is the only, I have given you slideshow and I've shown you some of the PCBs where how it is made, how it is manufactured. In the coming video, I will tell you the process, that is step-by-step process, how you will make with the help of a software. I hope you like this video. Please watch, subscribe, and give your suggestions or this thing that what you want to learn. I will be making those videos for you. Thank you for watching.